Good morning, class. Our topic for discussion today is all about the chemical properties of soils. So, laboratory lecture tayo ngayon, and we're going to take up the chemical properties of soils. Letter A, soil colloids. Colloid is a homogeneous. When we say homogeneous, it contains one phase, but differ from the other homogeneous substances like what you see in the figure. Nakikita natin yung unang flask o yung unang glass ay nagta-travel yung liwanag pagka nilagyan natin ng flashlight. Yung nasa sa gitna ay colloid, at yung nasa sa kulay pula ay suspension. So we have different types of mixtures in chemistry. Dinidiscuss ito sa inorganic. We have types of solutions. We have the solutions, yung unang gray, then colloids, then the suspension. Okay, so what is the difference between the three? Why did it called the solution, suspension, and colloid? So ang diferensya nila, lahat ng solution ay mayroong dalawang phase system, isang solute at saka isang solvent. Isang solute at isang solvent. Doon sa solution, ang definition nito ay the particles being dissolved in a solution is always transparent, meaning you can see what is behind the container. Kung ilalagay natin siya sa transparent na container, yung figure ay makikita natin sa kabila. Ibig sabihin transparent siya. The solvent, yung part ng solution, solvent and solute. Yung solute ay natunaw completely, kaya naging transparent. Ang example niyang solution na yan, yung asukal at saka yung asin. Pag tinunaw natin sa tubig, nagiging solution siya. So in the colloidal system, in colloidal example, pag sinabi natin colloid, meron siyang Tyndall effect. When we say Tyndall effect, pagka nilagyan natin ng flashlight dun sa tabi ng kanyang container, even if the transparent yung bote o yung glass, ay hindi siya magta-travel, bagkus siya ay i-scatter yung liwanag dito, i-scatter yung liwanag dun sa buong bote, hindi siya lalampas. And ganun din yung suspension, pagka nilagyan natin yung liwanag ng flashlight dun sa tabi ng bote o ng glass, ay hindi lalampas doon sa baso yung liwanag. So it means that the colloidal particles or the solute contains larger particles than that of the solution. And ganun din yung suspension. Ang diferensya lamang, kaya suspension ito, madaling nagse-settle down yung solid particles ng suspension solution kaysa sa dun sa colloid. Yung colloid ay hindi bumababa agad yung kanyang solid particles. Nananatili siyang suspended sa above, in the middle of the suspension or the solution, I mean. Okay? So in this in the definition of the colloid, hindi muna tayo dun sa soil colloid. Colloid is a homogeneous. When we say homogeneous, they have one physical property. Isa lang yung makikita natin din sa kanyang pagiging phase. Non-crystalline, they are not solid. Substance consisting of large molecules on or ultramicroscopic particles of one substance dispersed through a second substance. The colloidal state refers to two-phase system. Ang colloidal state daw of matter is composed of two-phase system. Ibig sabihin, dalawang parte o phase. Yung unang phase ay liquid, yung solvent, let's say water. And the second phase is a solid, usually solid, kaya nga siya ay nagsuspend. Ito ang isang magandang example nito ay pagka umulan, yung ilog ay nalalabo. Pag bumaha, nalalabo yung ilog. At yung tubig sa ilog ay may kasamang lupa. Yung lupa na parte dun sa solution ng tubig na labo ay yun yung colloidal particles. At yung malinaw doon, pagkatapos tumining siya after some time, ang tawag doon ay water o liquid phase. Ang mga halimbawa ng colloid ay solid in liquid, katulad ng dispersion of clay in water, and liquid in gas, katulad ng fog or clouds in the atmosphere. So yung liquid na fog yun ay in gas, in the atmosphere, that is ay colloid. Colloid. Para bang yung nagsaing kayo, lumabas yung usok dun sa takip ng kaldero. Yung usok na yon in one phase as gaseous part of the atmosphere ay naging colloid. After some time, mawawala din yung colloidal particles kasi sumasama na nga sa hangin. Pero yung iba nagiging cloud, nagiging cloud. Usually yung mga usok ay nagiging cloud. Okay? The clay fraction of soil contains particles less than 0.002 mm. Paano ko pa kaya ng sukat ito? In size, particle less than 0.001 millimeter size possess colloidal properties and are known as soil colloids. Ay, yung particles daw ng soil na may size na 0.001 mm in size, kapag humalo sa tubig at nagsuspend, ay siya ay nagiging soil colloid. So in definition, soil colloids are the most active constituent of the soil and determine the physical and chemical properties of the soil. Ang colloid daw ng soil ay pinaka-aktibong parte ng lupa, at ito ang nagsasaad ng kanyang physical at chemical na katayuan ng lupa. Sila ay mahalaga sapagkat yung surface ng lupa, o surface ng colloid ay doon na dumidikit o doon na huhumaling yung mga soil nutrients na natunaw sa tubig sa lupa. Water as possibly charged mineral ions or cations. In this article, we have explained the concept, types, properties, and importance of soil colloids. Soil is composed of organic matter. Ayan, sabi dito, yung lupa daw ay may kasamang organic matter. Alam na naman siguro ninyo yung organic matter, that is the animal and plant debris that is decomposed in the soil for some time. Yung mineral, gases, liquid, and organisms. So yung minerals, yung mga hindi mabubuhay, katulad ng kaolinite, mga gypsum, aluminum oxide, yung mga lupa yun. Gases, liquids, and organisms that together support life. It is responsible for plant growth, means of water storage, supply and purification, modifier of atmosphere and habitat for living organism. So this is the concept of soil including the amount or the composition, living and non-living composition of the soil. If you are going to analyze the figure in this part, we have the high ECE. Ano ibig sabihin nito? Dito sa first figure sa kaliwa, ang madaming mga positive and negative na mga positive and positive charge, mga ions, cation particularly. Ito yung matataas, ang colloid na may matataas na high CE, CEC. Pag sinabi natin CEC ay cation exchange capacity. Ang ibig sabihin ng cation exchange capacity ay kakayanan ng soil colloid na tumanggap ng mga mag-attract ng mga positively charged ion para siya ay nananatiling para siya ay nananatiling available doon sa surface ng lupa once na kinailangan ng ugat ng halaman para sila ay sumama sa tubig pagka sila ay sinipsip. Okay? So yung low is CEC naman ay low cation exchange capacity. Usually ito ay nangyayari kapag mababa yung moisture ng colloid at yung properties mo ng colloid. Okay, so mas mataas na CEC ng lupa o ng soil colloid, mas mataas yung probability na siya ay mas magiging productive yung lupa at mas magiging mataas ang kanyang nutrition. So we have general properties of colloids. We have size. The inorganic and organic colloids are extremely small size, than micrometers in diameter. This particle cannot be seen using the ordinary light microscope, but can be seen only on electron microscope. So generally, katulad ng ating sinabi kanina, the size or sizes of colloidal particles are extremely small, as size at 0.001 millimeter. 0.001 millimeter dito. 0.001 millimeter. 0.002 yung particle size. Halos magkaano. Surface area, ibig sabihin itong surface area, mas maliit daw yung colloidal particles o yung colloid na particle ng colloid, mas madami daw ang surface area. At mas madami daw ang surface area, mas malaki yung chance na sila ay maging fertile sapagkat mas na-attract yung moisture, yung tubig sa kanila. At kung na-attract yung tubig, maraming na-attract na negative charges. Once na maka-attract ng maraming negative charges, maraming mga positive cation ang pwede nilang makuha subject for the process of absorption. So kung ikukumpara daw sa isang gramo ng colloidal clay ay 1,000 beses daw na mas malaki ang surface area ng buhangin kung ikukumpara sa 1 gramo ng buhangin. So kung ating iisipin mabuti, ano ba ang surface area? So nandito sa figure kung ano yung makikita natin. Meron tayong ilang box. So we have 1, 2, 3, 4 figure containing boxes. Yung unang box, merong 1 mm na length times width times thickness. 1 cubic millimeter. Now, when we divide into 2 the cube, sabi natin lengthwise yun, dinivide natin. So, yung surface noong cube ay nadagdagan na. Kung itong cube na ito ay nauna, yung isa ay 6 ang surface nito, yung pangalawang cube ay 12 na. 12 ang surface. At yung unang cube ay mas maunti ang chances na maka-attract ng positively charged ions or cation kung ikukumpara dito sa dalawa. Now, hinati pa natin sa 8 yung paliit ay paliit yung yung solid particle na ito. Yung dalawa ginawa na, hinati pa uli natin sa dalawa yung sa apat pala. So anong nangyari? Lumaki ng lumaki. Kada isang box dito ay meron itong 6 na surface area. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 6 na ngayon ang surface area nito. Kaya nga sinasabi dito, mas malaki yung surface area ng colloid na maliliit kaysa doon sa surface area ng malalaking buhangin. Parehong 1 gramo sila. Okay. The colloid surface area in the upper 15 cm hectare of clay soil could be as high as 700,000. Ayan, yung colloid surface daw doon sa ibabang bahagi ng lupa na 15 cm ang lalim ng putik na lupa ay mataas o mas kasing taas ng 700,000 metro kubiko. Ayan, metro kubiko per gramo. Okay. So next, surface charges. Katulad ng sinabi ko kanina, mas maraming surface area, mas marami ang chances na maging fertile yung lupa. Sapagkat mas marami yung moisture, mas maraming negative ion ang makukuha o didikit, mas maraming maa-attract na positive ion ang mag-a-absorb dun sa surface noong maliliit na surface charges. So ito yung mga ion at cation. Both external and internal surfaces of colloids carry negative or positive charges. Most of the organic or inorganic soil colloids carry negative charge. Ayan. Kalimitan daw ng organic soil colloids ay may daladalang negative charges o nangangahulugan na kung sila ay single element atom, ang daladala lagi usually nila ay negative charges. Kapag pinadaan na daw natin ng electric current doon sa suspension, may kahalong lupa na tubig, inalo natin. Yung soil colloidal particles may migrate to anode. Nilagyan natin ng may anode, yung positive negative charge nung kuryente. Ating sinaksak sa kuryente, dalawang portion yon, anode at saka cathode ba yon? Then the positive electrode indicating that they carry a negative charge, Okay. So yung positive electrode daw ay mag-indicate they migrate to anode. Ibig sabihin yung anode ay positive electrode. Sila ay may daladala o magpapakita ng negative charges. The magnitude of charge is known as zeta potential. The presence of intensity of the particle charge influence the attraction and repulsion of particles toward each other. So this has something to do with surface charges, has something to do with the attraction of positive and negative charges of an ion. Usually the larger the negative charges, the larger the negative charges, the larger the chance of attracting the positive charges, which is the necessary elemental nutrients necessary for the growth and development of plants. So the sources of negative charge on clay comes from dalawa ang pinanggalingan ng negative charges ng lupa. Mula ito sa ionizable hydrogen ion. So ionizable, usually ang ating lupa ay mataas ang hydrogen content. So kung naging ion sila, ibig sabihin ng ionizable hydrogen ion, yung hydrogen element or atom na nagkakaroon ng charges, either the positive or negative. And isomorphous substitution, so when we say isomorphous, nilipat lamang yung mga charges. Okay? So yung soil components, halimbawa ay ang pH ay 3.5, mataas ang pH, maraming hydrogen na negative. So malaki yung chances na mag-attract siya ng charges, positive and negative. So mas maasim yung lupa, mas makakaunti yung ma-attract na na positive charge or ng mga minerals na kailangan ng halaman. So sa 5.3, ayan, makikita kung ilan lamang yung 5.3 na pH, usually malapit na ito sa 7, ay 1, 2, 3, 4, 5, 6, 7, 8, 9. Siyam lamang na element yung pwede niyang ma-attract o dumikit dun sa colloid. Samantalang kung ang pH niya ay 7, which is neutral, ibig sabihin hindi maasim, hindi mapakla, maalat, ay madami. 10 yung kanyang pwedeng ma-attract na element at na ion, positive ion. So it is therefore understood that the higher the hydrogen concentration of the soil, the higher the amount of cation are expected to be attracted by the colloidal particles of the soil. Okay? Then next, ionizable hydrogen ion. Ito na nga yun, binanggit ko. These are the hydrogen from the hydroxyl group ions on the clay surface. The aluminum hydroxide or silicon hydroxide portion of the clay ionizes the hydrogen and leaves an unneutralized negative charge of the oxygen. So yung yung hydrogen dun sa oxide, dun sa aluminum at saka dun sa silicon na putik ay magta-transfer dun sa aluminum oxide at saka silicon oxide. Magiging dahilan ito na tumaas ang pH o kaasiman ng lupa. So dito naman sa isomorphous substitution, pag sinabi natin iso, ibig sabihin ay hindi pangkaraniwan. Pag sinabi natin morphous, from the word morphology, ibig sabihin ay dun sa pagiging itsura, yung morphology niya, yung itsura ng kanyang pagiging colloid. Pag sinabi natin isomorphous, yung morphological status or itsura noong colloid ay hindi pangkaraniwan kasi isomorphous substitution. This is due to the substitution of cation of higher valence. Alam naman natin kung ano yung valence, with other cation of lower valence but similar size in the clay crystal structure. In clay crystal, some ions fit exactly into the mineral lattice sites because of their convenient size and charge. Okay, so itong isomorphous substitution naiilipat noong cation or nung clay surface, yung cation na may mataas na valence papunta dun sa cation na may mababang valence. Subalit sila ay naiilipat doon sa mga clay crystal structure. Dahil nga magka-similar sila, similar yung kanilang morphological properties, ay naiilipat sila even if magkaiba yung kanilang valence electrons. Yung clay crystal of some ion ay kumbaga umaakumak dito sa mineral lattice sites o dun sa lugar kung saan magkakapareho yung sizes at charge nila. Yung mataas na clay o madaming clay, positive 4 na silicon is tetrahedral sites, and aluminum na positive 3 in octahedral sites. When we say tetrahedral ay ito yung mga crystal na may 4 na kantuhan ng pagiging crystal nila, samantalang ito namang aluminum na octahedral site ay mayroong 8 plane dun sa kanilang pagiging colloid. Other ion present in large amount during clay crystallization can replace some of aluminum 3 and silicon 4 positive. So yung aluminum na may valence na 3 at yung silicon na valence 4 pwedeng mag-exchange at pwedeng lumipat, pero pareho din yung kanilang colloidal size ng colloidal particles. So this is supposed to be not being permitted by nature because magkaiba nga yung Bell selector, pero kung pareho yung kanilang size at charges, o yung size ay mag-undergo ito. The total negative charge from the anion remains unchanged, and the lower positive charge of substituted cation result in excess negative charges on clay crystals. The total negative charge daw, total negative charge ng mga anion, particularly oxygen, ay nananatiling hindi nagpapalit. Yung mababang mga charge na mga substituted o ipinalit na cation ay magre-resulta sa sobrang dami na clay charge ng clay crystal. So yun yung yung explanation dun sa isomorphous substitution. Okay, let us go to the adsorption of cation. When we say adsorption of cation, it has something to do with the attachment of a molecule of gas or liquid solute as thin film in the surfaces of colloidal particles. Yung pagdikit, adsorption means attachment o pagdikit doon sa surface ng lupa, particle ng lupa, in the form of thin film. Habang yung mga soil colloid ay mayroong negative charge, they attract and attach the ions of positive charge to the colloidal surface. Ang pwedeng maka-attract sa cation nila ay hydrogen plus, positive, aluminum, calcium, and magnesium. At ito yung nagbibigay ng daan para magkaroon ng double layer ng mga element na mga ion doon sa isang colloidal particle. The isomorphous substitution in colloidal particle makes the external and internal layers of clay negatively charged, and these surfaces act as a huge anion which form the inner layer of the double layer. So, yung pagkaka-attract o yung adsorption ng cation ay nagbibigay ng yung internal layer, yung loob ng clay at labas, nagbibigay ng mataas na negative charge sa surface na iyon, naging dahilan upang dumami ang anion, which form in the layer, the inner layer of the double layer. So yung layer na inner layer ang nag-provide noon, ang naging dahilan noon ay yung isomorphous substitution, which form the inner layer. So yung outer layer naman ay yung attraction nung mga positive na cation. Adsorption of water. So this is also one of the reason why cations are being attracted or absorbed by the colloidal particles. A large number of water molecules are associated with soil colloidal particles. Some water molecules are attracted to the absorbed cation, and the cation is said to be in hydrated states. Other water molecules are held in the internal surfaces of colloidal clays, and these water molecules play a critical role in determining both physical and chemical processes. So as I said a while ago, adsorption of water outside the colloidal particle or the surfaces of the colloidal particle could attract negatively charged ions, and then when the surface of the colloidal particles increase in size or increase in negative charge, the attraction of positively charged ions facilitate into some extent. Ibig sabihin, dadami yung attraction na magiging kapag mas madaming tubig ang na-attract dun sa soil particles. Cohesion. Cohesion. This is the force of attraction between. So, pag sinabi natin cohesion ay parang namamagnet. Namamagnet. Indicate the tendency of clay particle to stay together. Cohesion. Parang yung yung pinagdikit-dikit mo yung daliri mo. pinagdikit-dikit ko yung daliri, no? Yung daliri mo ganyan. Pagkatapos ito ay pag pinaghihiwalay mo, hindi mo makaya ihiwalay kasi dun sa cohesive forces na nagawa nung apat na daliri. So the attraction nung molecules to stick together. Adhesion. So when we say adhesion, the attractive force between molecules or materials. So what is the difference between cohesion and adhesion? When we say cohesion, the tendency of clay to stick together. Ibig sabihin pare-pareho yung clay. Ibig sabihin ay hindi dito pinag-uusapan yung molecular basis. Ang pinag-uusapan dito ay yung pagkakadikit-dikit ng clay particles. When we say adhesion naman, yung lalo sa salitang adhesive, pampadikit, attractive force between different molecules or materials. Attractive force between different magkaiba, halimbawa ay yung pampatsin natin na duct tape or kahit ang tape, tapos ito yung page ng libro, yung papel, so didikit siya, so adhesion yun, kaya nga adhesive ba. Number 8, swelling and shrinkage. So yung swelling and shrinkage ay kaakibat din ng sizes ng colloidal particles. Pag sinabi natin swelling, pamamaga, ibig sabihin ay lalo na pagka yung maraming ulan, bumaha, o kaya naman yung lupa ay natungtungan habang basa siya, mamamaga siya, magiging siyang putik. At ano mangyayari pag wala ang tubig, siya ngayon ay kukupis o liliit siya hanggang sa magkabitak-bitak. Some soil clay colloids belonging to smectite group, like montmorillonite, swell when wet and shrink when dry. So ito yung mga lupa na matatagpuan natin sa mga katubiganan. Soil classification natin diyan, isa siyang vertisols. After a prolonged dry spell, pag mahaba daw yung pagtuyo ay yung smectite clay, lalo na yung mga itim na lupa, vertisol, ay kalimitang nagkakaroon ng mga bitak-bitak malalalim. And this crack allows rain to penetrate rapidly, and later because of swelling, the cracks, yung mga bitak ay mawawala at magiging impervious, o hindi naman natin malalagyan ng tubig sa ilalim. But soils dominated by kaolinite, chlorite, and fine grade mica do not swell or shrink. Vermiculite is intermediate. Ibig sabihin yung kaolinite, chlorite, at fine grade mica or mica, hindi sila namamaga o hindi sila nagiging putik. Yung namang vermiculite ay hindi namamaga at hindi rin siya hindi nalaki at hindi naliit kahit siya basain o kahit siya tuyuin. So dispersion and flocculation. Dispersion is the action process of distributing soil over a medium, while flocculation is a process by which chemical coagulant added to water act to facilitate bonding between particles, creating larger aggregates which are easier to separate. Pag sinabi nating dispersion, pinapakalat natin. Halimbawa, naghulog tayo ng isang parte ng putik sa lupa, basang putik, nilagay natin sa basong tubig, so makikita natin kumakalat yung labong tubig. Yung particle ng clay o yung colloidal particles ng clay kumakalat at nagpapalabo yun sa lupa. Tawag doon ay dispersion. Flocculation naman ay proseso kung saan yung chemical coagulant, merong chemical na pag inilagay sa lupa, nagbubuo-buo. Coagulant ang tawag dun sa chemical na nagpapabuo-buo ng mga particles, at nagke-create sila ng aggregates. Walang pinagkaiba yun dun sa process na ginagawa din sa keso para maging sa gatas para maging keso. Nabuo yung keso. So that is the coagulation process. As long as the colloidal particles remain negatively charged, they repel each other and the suspension remains stable. Ano. Kapag yung particles daw ay naging negatively charged, sila ay hindi na nagsasama-sama, ano, at yung suspension ay nananatiling stable, ano, hindi na nagagalaw. If on any account they lose their charge, kapag kung ano pa mang paraan ay nawala yung kanilang charge, yung pagiging ion nila, ang kanilang charge, ang magnitudes ng charge ay mababawas. The particles coalesce. The particles coalesce, ano bang ibig sabihin ng coalesce na ito? Sabi ng mga bata. Merge, ano, nagsama-sama. Merge. Ganun din, nag-coagulate din. From flock of loose aggregates. Ano, nagsama-sama, form, flock. Ano, nagbuo ng paksyon o ng sama-sama na buhaghag na aggregates and settle down, pupunta sa mababa dun sa solution. Okay, so next is the Brownian movement. Ano, itong Brownian movement. This is defined as the erratic random movement of microscopic particles in a fluid. Parang ito yung kinetic molecular theory sa chemistry. Lalong-lalo na kung ang pinag-uusapan ay hangin or gas molecules. Pagka nakasilid yung gas doon sa loob, palipad-lipad yung gas molecules sa loob ng container. So kung ito yung solid or lupa na nasa suspension, ganun din, movement of molecules and other materials in the container or in the soil. So that is the Brownian movement. Non-permeability naman ay ibig sabihin ay hindi napapasok ng nasa labas na liquid particles yung loob ng colloid. Hindi, kumbaga kung tubig ang kanyang pinuntahan o tubig ang nagpunta doon o nilagay doon sa colloidal particles, hindi makakapasok yung tubig doon sa loob dahil siya ay non-permeable. Meron siyang membrane na nakabalot doon sa lupa usually na nagiging dahilan upang hindi pasukin ng tubig yung colloid. Meron siyang isang nakabalot na kung tawagin natin ay semi-permeable membrane. Okay, hanggang dito na lamang ang aking properties of soil particles at nawa ay maintindihan ninyo ang aking diniscuss ngayon. Sa susunod ay types of colloids naman, then the types of colloids, then we have the importance of soil colloids ang didiscussin nyo, sir. Okay? So, pansamantala muna, dito muna tayo titigil.